So here's the example we're going to do 3 different times. We'll do it first here in the traditional method. Next we'll do it just keeping track of X and Y components. And finally we'll use the shortcut that I'm trying to teach you. These are 15 feet wide and 20 feet tall, the triangles, which makes these 3, 4, 5 triangles. Okay, I've drawn the free body diagram for the truss here. Here are the reactions. There's no X forces, so that X reaction is 0. And you know how to do statics. I'm just going to do this real quickly. The reaction at D, due to that 12 kip load, is 1/3 of that, so that's 4 kips, and at A is 8 kips. The 24 kips, 2/3 of that is at D, 16 kips, which means there's, what's that, 1/3 of 24 is 8 kips. I'm just doing this to be quick. You should do the real statics, but if you do that, you should end up with 16 kips at A and 20 kips at D. Next, I'm going to draw the free body diagram of every joint with what we know. So we know that this is 16 kips there. That's 0. And if we don't know what a force is, I'm just going to draw it in tension. So that's FAE, FAB. And equal and opposite, there will be a FAB there. And this is a FAE pointing from E to A. Okay, up here at joint E, there's a FEB and FEF, all unknown. Let's go down to joint B. Their equal and opposite is that FEB. That diagonal is going from FBF. You know, FB, FBF, those are all the same. You can change the letters, it doesn't really matter. And this is FB to C, and we know that this is 12 at joint B. At joint C, we have this 24 kips down. We have FCF, which is going to be 24, obviously. FCD and FBC. Let's go up to joint F. At joint F up here, we have this FCF, this one FBF, FEF, and FFD. And finally, over at joint D, we have this FFD, FCD. I wrote that wrong on over here. That should be FCD, and that reaction up there is 20 kips. Okay, so all I went through was I drew in the forces that I knew. I knew that 16, that 0, that 12, the 24, and the 20. And everything else is just an unknown tension. And I'm just trying to keep the letters the same. For example, FAB and FAB. But, you know, if I wrote FBA and FAB, those are the same thing. So all these joints are 2D particle equilibrium. So what we need to do now, we know that we'll have 2 equations. We have to hunt down all the joints that have only 2 unknowns. So this one here has only 2 unknowns, and this one here has 2 unknowns. Everything else has more than 2 unknowns, so we'll have to start with these 2. And what I'm going to do is I'm going to use this drawing up here as our scorecard. So as I solve for forces, I'll draw them in up there. Okay, so let's start with joint A. So here we have joint A. I'm going to redraw the free body diagram there. FAE, FAB, and 16 kips going up. I'm going to sum forces in the y direction first. I noticed that there is FAE has a y component, but FAB doesn't, so I'll be able to solve that directly. And then once I do that, I can sum forces in the x direction. So sum Fy equals 0. I'll take up as positive. It's a 3, 4, 5 triangle. So the y component is 4/5 or 0.8. So 0.8 FAE plus 16 equals 0. That means FAE is minus 20, which means compression, because away, I drew them all away as in tension, and so it's coming into the joint as compression. Now let's do sum Fx equals 0. We have FAE is now minus 20. The x component is 3/5 or 0.6 plus FAB equals 0, and that means FAB is 12, and it's positive, so in tension. What I'm going to go do now is go back up to our little score sheet and write in those answers. I'm going to write the actual answers in green. So we had FAB was 12 in tension, and we had FAE was 20 in compression. So I'm going to change that to a 20. And what I'm going to immediately do is, by Newton's third law, equal and opposite, on the other side of AE, I'm going to draw the opposite. So if you have 20 kips pointing into A, you have to have 20 kips pointing into E. Okay? So these are equal and opposite. Similarly, if FAB is pulling on A with 12, it has to be pulling on B with 12. Now what we have to do is look and see if there are any more joints with only 2 unknowns. And so we see that, oh, look at joint E. Now that we know that FAE is 20, that one now only has 2 unknowns. We can do that one. Or we could do this joint over here, joint D. Let's go ahead and do E next. Okay, here we go, joint E. I'm going to draw the free body diagram. We know that this is 20 now. And FEB, FEF. Doesn't matter, X or Y components. I'll do X first this time. Sum Fx equals 0. To the right is positive. That 20, these are all 3, 4, 5 triangles. I made them all the same angles to make it easy. The x component at 20 is 0.6 times 20 to the right, plus FEF equals 0. That means FEF equals minus 12 kips, which means compression. Next, let's do the y component. So we have sum Fy equals 0. We're going to go up. The y component at 20 is 0.8 times 20. It's positive going up. And I've drawn FEB going down, so minus FEB equals 0. And that means FEB equals positive 16, or tension. So what I'm going to go do now is go back up to the scorecard and draw these in. Again, drawing the answers in green, we had FEF was 12 kips in compression. So compression points into the joint. And we had FEB was 16 kips tension, and tension is pulling. And what I'm going to do again is just go to the partner joint. E is connected to F. So if it's pushing into E with 12, it's pushing into F with 12. So let me draw that way. And if EB is pulling from E with 16, it's also pulling from B with 16. Okay, let's look around for which joints now have only 2 unknowns. Joint F still has 3 unknowns. We could do joint D, but look, joint B now has only 2 unknowns because we've gotten rid of 2 of them. Let's do joint B next. Okay, next is joint B. Draw a free body diagram for that. It's got quite a few forces on there. We have that 12 that's applied. We solved for this 12, this 16 going up, and here are 2 unknowns, F, B, F, and F, B, C. Okay, so let me try to explain this again. F, about which equation to do first. FBF has an x component and FBC obviously has an x component. So if I did the x equation first, I would have 2 unknowns. However, when I look in the y direction, FBF has a y component but FBC doesn't. So I'm going to do the y component first because it only involves 1 unknown. So let's do sum Fy equals 0 up as positive. We have that 16 going up, that 12 going down, and the y component of FBF is 0.8 times FBF because it's a 3, 4, 5 triangle. In a regular truss, you'd have all these angles and you'd be taking sines and cosines. It wouldn't be this nice. And that will all add up to 0. And I'm going to solve for FBF and come right back. I get that FBF is positive 5, which means tension. Now that I have FBF, I'll be able to solve for FBC. We'll take sum Fx equals 0 to the right as positive. We have the 12 going to the left, and we have FBF. We need the x component of that, which is 0.6 times FBF, which we just solved, is 5, plus FBC equals 0. I'll solve for FBC and come back. I get that FBC is plus 9, which again is tension. Let's put these 2 forces up on the diagram and see where we are. So we have FBF is 5 tension and FBC is 9 tension. Okay, we have FBF was 5 tension, and we had FBC was 9 tension. And I'm going to put the opposite on the neighbor joints. So there's FBC 9 and FBF 5. Okay, we can now do joint C here. That now has only 2 unknowns, and it's pretty easy, but I'll do the free body diagram and do the whole thing. So here is the free body diagram for joint C, and I'm actually not going to write out the equations. Can you just see that obviously FCD is 9 in tension and FCF is 24 in tension? That 9 is pulling to the left, so FCD must be pulling to the right. That 24 is down, FCF is going up. And those are both away from the joint, so they're both tension. I'm going to put those back up on our little score sheet. Okay, we got that FCF was 24, so I'm going to put the opposite there. And we got that FCD was 9, and I'm going to put the opposite there. Okay, we just have one last force to do, FFD. Why don't we do joint D, and then we'll do joint F just to double check. So let's do joint D next. Okay, here is the free body diagram for joint D. We just have one unknown, so let's do sum Fy equals 0. And we'll have 0.8 FFD plus 20 equals 0, which means FFD equals minus 25, or 25 in compression. Okay, let's check that sum Fx equals 0, and we have minus 9 plus, we just got that it was minus 25 times 0.6 is the x component. Does that equal 0? Let me check. Actually, this was plus because FFD is in compression, so it's pointing into the joint, so the x component is going to the right. So we have minus 9 plus 0.6 times 25 is actually, let's see, 15. That does not equal 0. So this means somewhere on this page we have made a mistake and we have to start all over and find our mistake. This is just the nature of solving these things by joints. Just one mistake anywhere and it won't come out in the end. I went through those reactions pretty quickly. I'll bet I made a mistake in the reactions. I'm going to double check the reactions and come back. So no, I did get the reactions right. So that means that just somewhere in one of these joints I've made a mistake. You can see how this is very tedious, how it's very prone to error. So I'm going to slowly introduce a new technique. Ultimately, the shortcut technique I'll teach you is very foolproof and very easy to see where our errors are. So this next example I'm going to do, where I keep track of just the x and y components, is just a halfway step to the full-blown shortcut, which is really how I do things. So this was example 1, I got it wrong. Next we're going to do example 2, the same problem, but just keeping track of x and y components.